I'm a reader in electronic engineering and physics at Manchester Metropolitan University, and my job really encompasses some teaching and some research, so I split my time between those two activities. This is a system that uses millimetre wave radiation. Millimetre waves are electromagnetic radiation, so similar to light, but the wavelength is many times longer, in fact several thousand times longer than light. So you can't see it with your eyes, and they're very low power, so typically the power output of this device is 1/1000th of a watt, and you have to contrast that, say, to your mobile phone. A mobile phone will transmit up to 5 watts of power. So 5,000 times more power will come out of your mobile phone as electromagnetic waves than out of this system. So it's very low power, and it transmits a pulse of millimetre waves which reflect off the body, and because they can penetrate through clothing, they don't really reflect off the clothing, they reflect off the skin or anything that you've got under your clothing. So I guess you could think of it as a radar system or like a bat sonar system. If you were familiar, the only time that you would ever come across millimetre wave imaging, and you wouldn't see the images, would be in an airport where you walk into a body scanner and you'll be scanned, and the machine will decide whether or not you're carrying any objects you shouldn't be. If you think when you go through an airport system, they're big, they're bulky, you can't really move them around, they need to be placed in there and they don't move. Whereas the system here is lightweight, it can be deployed very rapidly. So you can conceive that, for example, at sporting events or court cases or anywhere where there would be heightened security risk, you could deploy these devices to screen people.
How does it manage to detect what's a weapon and what isn't?
Well, that's the software. So the way the radiation is, the electromagnetic waves are scattered back from the person, tells you something about what they've reflected off of, and some software in there does some quite complicated analysis and decides whether it's reflected simply off of skin, or it's reflected off your mobile phone or a bunch of keys or your wallet, or it's reflected off something that it's really interested in, like a handgun or a knife. Recently we reassigned the intellectual property, so the research itself is now owned by a small company which is looking to commercialise and sell these systems. Now, I can't say all of the customers that they're selling to, but we've had great interest from the US Army, the Department of Homeland Security in the US. So any government body whose remit is to protect civilians from anything from people carrying knives and handguns right through to explosive devices. So originally this system was developed under funding by the Metropolitan Police Service, and they wanted to be able to spot gang members carrying knives and guns on the streets of London. So that was back in 2006 that it all started up, and there's been a great many people at MMU involved in that, and I'd like to mention their names. So Dave Andrews, Dr. David Andrews, Dr. Matthew Southgate, who's done all the electronics, obviously Professor Nicholas Bowring, whose idea it was originally, and he's been with it since right from the very early days. And we've got Dr. Nasser Rezgi, he's been involved in doing some of the calculations, and myself. So it's been a big group effort to get this to where it is now.